Ch04 Q18. We've got a leg and cast here that have a force of gravity or a weight of 220 newtons, and they need to figure out what the weight you need to apply and at what angle so that no net force is applied on it. If you take a look at this real quick, what we've got is we've got two tensions here. We actually know the tension over here is going to be 110 newtons. We don't know this tension over here. We do know the force of gravity, also called the weight on this one, is 220 going downward. If we break these into their components and do some really quick math on this one, just using sine and cosine on this side, we can very quickly work out that the upward force here is going to be 70.7 newtons. So that's the vertical component of that 110 newtons. And over here, the horizontal component is going to be 84.3 newtons. The moment we have those, we can immediately realize that this thing's in equilibrium. Let me write that below. It's kind of hard to see that one. 84.3. We know this thing has to be in equilibrium, which means the sum of the horizontal forces and the sum of the vertical forces must add up to 0. What does that mean at this point? It means this side over here has to also be 89.3 newtons. And the moment we know that, we can solve, at least we know that side. But you might say, well, wait, what's this side over here? Well, we know that the sum of these two vertical components, the one on this side and this side, have to equal 210. So, 220. So 220 minus the 70.7, we can immediately figure out this side here has to be about 149 newtons to 3 sig figs. Now, we can solve for alpha, this angle here, just by using inverse tangent. We know the tangent of theta, in this case, has to equal the opposite side over adjacent side, 149, over the adjacent side, which is 89.3. And if we just do a little inverse tan of that real quick, give me a moment here as I solve that. Inverse tan of 149 divided by the 84.3. That's hard to see, actually. I wrote that. And it gives us theta, or in this case alpha, I should say, is 60.6 degrees. How do we find the magnitude of this force over here? There we can just use Pythagorean theorem for this right triangle. So just the 149 squared plus the 84.3 squared. The sum of that raised to the 1/2 power, or the square root of that, and we discover that this force here has to be about 171 newtons. So our two answers in this case, the weight over here, or the force of gravity on this thing, must be 171 newtons. And the angle that it's acting at has to be, or this angle over here, alpha, has to be about 60.6 degrees.